Hi friends, how are you all? Okay, so in the previous video, I was explained the operational control words of 8259. Nothing but operational control words or operational command words of 8259, right? So we have three types of operational command word 1, command word 2 and command word 3 we described. So now in this video, I will give you a brief idea about how we can interface 8086 with 8259. So in the normal mode as well as in the cascaded mode. Let us see in which way we can interface 8086 with 8259. Okay, I will make a full screen. Now let us see our topic interfacing 8086 with 8259. Okay, interfacing 8086 with 8259. Let us see here. This is your 8259. Okay, and this is your 8086. See, all these signals are coming from 8086. All are coming from 8086. Okay, this is your address decoder. IC number 74LS138. What is the role of address decoder? Address decoder will take the set of address lines from the processor and it will generate outputs, and those outputs are used to activate the peripheral devices. Okay, so generally address decoder not only activating the peripherals, and address decoder also provides address to peripherals. Okay, right. Let us see how they are connecting first, then later see what is the operation. Coming to address decoder, so generally address decoder VCC is connected to power supply, 5V supply. Then here in address decoder we have different inputs like A, B, C are the inputs of address decoder, whereas G1 bar, G2 bar and G are the control pins of address decoder. So G1 bar, G2 bar and G, if these three are activating, then only it will generate output. So one decoder will generate 8 outputs, whereas here only one is enough. That's why he highlighted only one output, but it will generate 8 outputs. All outputs are of value 0 whenever if you activate G1 bar, G and G2 bar. So all three must be activating. So when G1 bar is activating, here G1 bar is connected to ground, so it is now activating. So in which way we can activate G2 bars here? G2 bar having address lines. He considered A4, A5, A6 up to A7. A4, A5, A6 up to A7. In this example, 8 address lines he considered. Okay, so if it is this is nothing but direct mapping, IO mapped IO. Okay. So if you take 16 address lines, then it will go up to A15. So A4 to A15. Now, whereas here he considers A up to 7, we can take up to 15 also, not a problem. A4 to A7 in same manner. A4 to A15 for example, A4 to A15. So all are now connected to NAND gate. So when output of NAND is 0, if you give 0, then only G2 bar is activating. So when output of NAND is 0, assume if all inputs are 1s, A4 to A15 instead of A7, I'm calling as A15. Okay, A4 to A15. Assume all are 1s. Then what is the output of NAND? 0. 0 give it to G2 bar, then it will activate. Coming to G, I'm connecting here. He is connecting with M by IO by M bar. Okay, for IO operation, it's like a IO operation, so it should be 1. Then we are selecting IO, and because of 1 is connected to G, then it will activate. Okay, then A, B, C are the inputs of decoder. See here, A is connected to A1 address line, A2 is connected to B, A3 is connected to C. So we can select A1, A2, A3, either zeros or ones. Generally, if many are present, we can select some are 0, some are 1 because of combinations. But here only 1 is present. That's why A1, A2, A3 must be all here. Yes, A1, A2, A3. Right? So A0 is connected to A0 of this line. A0 is connected to A0 of this line. So assume now here we have 16 address lines, total A0 to A15. Here 7 is present. You consider like a 16 address lines in this example. So now how many address lines are present? A0 to A15. So A7 is not A7, A15 you consider. Then A4 to A15 must be all ones here. A4 to A15 must be all ones. Now we are selecting all are ones. Okay, then what is the next one? A here. After that, what is next one? We are selecting A0 is connected to A0. We can select, for example, A0 is 0. Okay, A0 is 0. 0 is connected to A0, then A0 is 0. A1, A2, A3. In that I am considering A1 is, I can select either 0 or 1. A2 and A3 must be zeros. Okay, so because of A1, if it is 0, then my address is here, total ones are there. 4 ones equal to F. Another 4 ones F. Another 4 ones F. Then if it is 0, 0, 0, 0, then address is 3F0H. Instead of 0, for example, if it is 1, then 3F2H is the address of A2 finite. So for example, here also I am assuming that A1, A2, A3 all are zeros because they are the inputs. Then what is the address? First one, 3F0H is the address of this particular A2 finite. So A2 finite is now available at which address? 3F0H, nothing but F0H is the address. For example, in this case, A1 is instead of 0, if it is 1, then address is 3F2H. Okay, so like that we can analyze. For example, instead of one master, if 3 masters are there, so then now A1, A2, A3, we can write 3 combinations: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, like that. Because of 3 inputs, we can find out address for 8 devices easily, like that. Okay, now in this case, address is 3F0H or 3F2H, depending on the value of A1. Consider first one, 3F0H is the address. Okay, now this is the way we can, decoder will give you address. Now what is the output of the decoder? Y naught. So whenever G1 bar, G and G2 bar are activating, then output Y naught should be 0. 0 will be given to CS bar. Then this 8259 is ready. Now here also one important point is we are making 8259 is like a master mode because only one 8259 is available. We are making like a master. In that case, what happens here? SP bar / EN bar is now connected to which one? VCC. And what is VCC value? 5 volts. Whenever SP bar / EN bar is connected to VCC, then it is not a slave. Now it is act like a master. Now it is master mode. Okay, and you know 8259 having 8 lines, 8 request line, IR0 to IR7, all are input to 8259. And 8259 having 3 cascade lines, CAS0, CAS1 and CAS2. If it is master, these lines are act like output. If it is slave, these lines are act like a input. Then ground is connected to ground. 8259 having 8 data lines, D0 to D7, and these data lines are connected to data bus of the processor, and data lines are bidirectional. Like that they are connecting. Similarly, read bar and write bar of 8259 are connected to read bar and write bar of the processor. Similarly, INT of 8259 is connected to INTR of the processor. Similarly, INTA bar of the processor is connected to INTA bar of the 8259. For example, if any, see in which way it will operate. For example, if any external peripheral device is requesting the processor for executing its instruction, then it will send the signal, interrupt request signal to any of IR0 to IR7. So, for example, take one slave. The slave is requesting 8259 with the help of IR0. After receiving the request, what happens? 8259 will sending interrupt request signal to processor with the help of INT. See this, with the help of INT signal, it will send request to processor for executing the instructions of slave with the help of INTR. If processor is ready, it will send interrupt acknowledgement to master. Then master will giving the corresponding information to slave with the help of cascade pins. Then the corresponding slave understood that processor is giving acknowledgement. Accordingly, these instructions are executed by processor. Like that, 8259 operates. Okay, if it is only one, normal mode. If it is cascade mode, what happens? In that case, one is master and other are slaves. Let us see how they are connected. Here other diagram. This is the diagram. Here, if you observe carefully, here also we use same address decoder. Okay, here G1 bar, ground. Let us see. What is your observation? It's a 38259 in the cascade mode. So in order to make a diagram a little bit visuality, we are considering 38259 only. Like that, one master is connected to 8 more 8259. Nothing but one master and 8 slaves we can connect. Okay, just here in this example, we can consider 38259. One is master and 2 are slaves. Okay, let us see how we can connect. Here also we are taking 74LS138 is the address decoder, and here also G1 bar, G2 bar. Okay, G are considered G1 bar, G2 bar, and G. Just for a change, G is now connected to VCC. Nothing but power supply pin. Okay, then G is activating. G1 bar is connected to M by IO bar. Okay, so whenever in order to activate IO bar, then it should be 0. 0 give it to G1 bar, then G1 bar is activating. So in which way we are activating the G2? So now here G2 is activating by connecting A4 to A15. Okay, A4 to A15. Now G1 bar, this is the G2 bar. Bar is missing. It is G2 bar. Remember G2 bar. Now A4 to A15 all are ones, then output of NAND is 0. 0 is given to G2 bar, then it will activate. Like that we are activating G2 bar, G and G1 bar. So whenever these three are activating, then this decoder generates 8 outputs, Y0 to Y7. But here how many external peripherals are available? 3. So 3 are enough. That's why he consider Y0, Y2 and Y4. So Y0 is connected to CS bar of first one, Y2 is connected to CS bar of second one, and Y4 is connected to CS bar of third one. Like that 3 8259 are there, 8259 2 and 3. Okay, so here also let us see A, B, C are the input lines of this address decoder, and A, B, C, A connected to A0, B connected to A2 and C connected to A3, and A0 is connected to A1. A0 address line is connected to A1 just for a change. It's not compulsory we follow like the same order. Okay, as per the connection we can write the corresponding address here. So A1 address line of processor is connected to A0 address line of the 8259. So same A1 is now connected to A0 of slaves also. Same A1 is connected to A0 of slave also. Then again, so now consider first master, 2 are slaves. Assume this is master, 8259 1 is master and other 2 are slaves. How to make this one as a master? See here, SP bar / EN bar is now connected to VCC of value 5 volts. Then this is act like a master. For other two, if you see, SP bar / EN bar is connected to ground. Similarly, SP bar / EN bar is connected to ground. Then these two are act like a slaves and this one is act like a master. So initially, the master will assign initialization code to each slave with the help of which line CAS0, CAS0, CAS1 and CAS2. Initially, with the help of these 3 bits, here these 3 bits are the inputs to slaves and output for the master. So with the help of these 3 bits, master sending initialization code to slaves here. These 3 lines are connected to slave 1. Similarly, 3 lines are connected to slave 2. So for example, master giving initialization code to slave at 000. For example, this one is initialization code is 001. Like that, it will send 3-bit initialization code to each slave. Okay. Now let us see here, read bar, write bar. Read bar is connected to read bar of processor. Write bar is connected to write bar of processor. Here also read bar is connected to read bar of processor. Write bar is connected to write bar of the processor. And INTA bar is connected to INTA bar of the processor. Here also INTA bar is connected to INTA bar. Here also INTA bar is connected to INTA bar. And all data lines D0 to D7. Similarly, here also D0 to D7. D0 to D7. All are connected to processor data bus D0 to D7. So here D0 to D7. All are connecting. But if you observe carefully, see the master INT is connected to INTR of processor. Here actually INTR. Remember INTR. See the master INT is connected to processor INTR only. But the slaves INTs, here the slaves, assume this is slave, this is slave. The slave INT is connected to which one? Master's IR0. Means the slaves requesting the processor for executing its instructions through 8259. So slave is simply giving interrupt request signal to master with the help of interrupt request pins IR0 to IR7. So because 2 slaves are there, that's why 2 connections. See INT of slave, first slave is connected to IR0. So INT of second slave is connected to IR1. So okay, like that these 2 are connecting. So see here slaves may not connect. Slave interrupt pins may not directly connected to processor. Only master interrupt pin is connected to processor, remember. So slaves are simply connecting interrupt request to IR0 and IR7 of master only. Okay, like that they are connecting. For example, now after receiving the interrupt request signals from the slave, master sending interrupt request signal to processor. So processor, at the time what happens, processor will complete the current instructions. Okay, after executing the current bus cycle, then what happens, processor will sending the interrupt acknowledgement signal to master as well as slaves also. All slaves. But after receiving the interrupt acknowledgement signal, master sending again the initialization code to the concerned slave. So for example, in these 2 slaves, so assume IR0 to IR7, IR0 is having highest priority than other. In that case, what happens, which slave is requesting the master with the help of IR0, okay, that master will execute the instructions. That master instructions are executed by processor. In that case, what happens, this master will sending initialization code to that particular slave first. Okay, it will again releasing the initialization code to the corresponding slave. Then the corresponding slave understood that processor is ready to executing its instructions. Then processor will execute the, processor will servicing the interrupts. Okay, after receiving the acknowledgement. Like that, master initially will provide initialization code to each slave, and after receiving the acknowledgement signal from the parser, again master sending initialization code to the corresponding slave. Okay, for making ready to ready, and its interrupt service is performed by processor. Okay, like that, 8259 master is performing the operation, okay, in association with the slaves and processor. Okay, like that, not only two slaves, we can connect 8 slaves to master. One master can receive request from 8 slaves. Okay, like that, we can interface 8086 with 8259 in the master mode as well as in the cascade mode of operation, right? So thank you for watching this video. I hope you understand the interfacing of 8086 with 8259 in normal mode as well as in the cascade mode. Okay, thank you so much.